It's 10 o'clock. I'll start the presentation. Small introduction. I'm the right one on the name, the left one is not there, Mr. Balajan. Quick introduction to both our companies. Zodius Corporation, 30% technology company, representation in France and in the US, and 50-year focus on managing complex data integration between tools. Delivering solutions worldwide to several companies. These are the usual slides, everybody has them, all the companies. But it's through all the names, and we are handling engineering data requirements, architecture models, UML models, everything. That's since 20 years. And we're together with Willett GmbH, that's my company, together with the big guy over there. We are a 20-person technology company and representation in Germany, in the very nice city of Bückeburg. Nobody knows where that is. From here, seen, this is in south of Sweden. So North Germany, we call it, but okay. We are focused since 27 years now already on embedded and model-based engineering. Cool, we are at home in all the fine edges of the V model, and we deliver lots and lots of tools in all these edges of the V model. And I will speak a little bit about these tools, and I'll speak a little bit about standardization. This is the combination Willett Zodius. We are at the moment in a merger, and in a half a year you will see the Zodius Willett logo instead of either Zodius or Willett. So we're cooperating mainly on all these requirements, systems engineering, software engineering. Okay, these were the two that give the presentation. You will see that I have some resemblance with the lower guy there, wearing a shirt and now wearing something else, but that's me. And I don't want to talk too much about myself. If you want to know more about myself, I only have half an hour. So you can join us on our booth, which is in hall 4, 150? Yep, 150. Good, the standards way of modeling. First, a little bit about the current situation. That's what we always like to do. What is the current situation? Problems that we have in the current situation is that we mostly have some issues with time. Time, is there some time continuity problem? No, there's not a time continuity problem, but the problem is that we normally don't have enough time for all the things that we want to do. This is a nice picture of the introduction of a couple of large cars of a company from Stuttgart. And in the car industry, it's very normal to think about a new model that they bring out. Mercedes has a 7-year range that they have, and every 7 years they bring out a new car. After 4 years they bring out the MOPF, the Modellpflege, so the update. But that is regulated, and they know exactly when they start this project. In 7 years, on this date, on this fair, we will introduce the new model, and this is, as I always compare it, it's like a solar eclipse or like sundown. There's no changing of that date anymore. Now the car industry is very heavy on that, but all the other industries also have the same problem. You all know it if you're an embedded developer. The boss says, how long will it take? You tell him, well, it's difficult. I think we will have to spend a year or so about it. Then we can make this project run. I say, okay, you have 3 months. That's the normal way of doing this. Yeah? And so that's one of the basic problems we have. Second is complexity. This is picture I made myself in a country far, far away from here, but it's just a sign of complexity, but that's not even a real complexity. The complexity nowadays is the lines of code that we have and the number of developers that we have that are developing code and developing software. What people underestimate most of the time, if you don't build cars, you don't know this. People always think, oh, we know the expression, we all know it. It's not rocket science. Well, trust me, rocket science is not complex. It is complex enough, but it's nothing compared to making an aeroplane or making a car. A luxury car, average luxury car now has 100 million lines of code. An average car, not even the navigation system of the 2009, that's 10 years old, S-Class Mercedes, 20 million lines of code. Average Ford, even in the US. I mean, we all know the Ford F-150, most sold car in the world. It's a miracle, but there is software in there. You would not believe it, but it is there. 10 million lines of code. A Dreamliner, 787, that's one of the newer airplanes of Boeing, 6.5 million lines of code. That's way less than in a car. The expectations are that now with the things that we do, self-driving cars, e-cars, that the number of lines of code of a car will increase in the next years to 800 million to 1 billion lines of code. 1 billion lines of code. Just let that number sink in a little bit. Next item, price. Minus 50%. So I took a picture of the website of Volkswagen, nice average German car manufacturer. Took me a while to figure it out, but this Touareg, whatever this SUV thingy, will set you back 58,000 euros. Okay, if you go to the configurator and you click a few options, you can scratch the 100,000, you can even cross the 100,000. But that's about the price of a very luxury car with everything in it. Airplanes. These are millions, that's not thousands. Just saying. The A380, okay, I think Airbus would like you to buy one. I think they just canceled it. It costs about $500 million. These are dollars, these are not euros. So mostly we have a price problem. In aeroplanes, the problem is not that big because they have a budget. If they need a blinking LED, they can just take a chip that is being certified, and if it's $10, yeah, whatever. In a car, oh, you have a price problem there because every cent is being calculated. So that is one of the problems that we have. And as I already said, the complexity is getting higher. We are working with more and more and more people to get this stuff done. So how are we going to do this? Well, not, apparently. I happen to have one of these Mercedes things, and when I had it, the first 6 months I had it, about 2.5 months of that it spent in the garage, people searching an error that nobody could find. It just stopped with me on the road while I was putting gas in it, tried to start it again, and it didn't work anymore. So it got towed away, and it was away for weeks. And then I got it back, and then it was away for weeks again. Because there was something in there and nobody could find it, and just exchanged some of these ECUs inside my car, and then it was working again. And I'm still hoping it will stay working. Sometimes it even behaves funny. Okay, I'm a software developer myself. Also, the people in the garage always say, yes, but you use everything. You should not do that. Normally people cross all the options but don't use it. They have no idea what it is, but I use everything. I even notice it when the menus change, when I have a software update. But I'm not the only one complaining. Here, look at that. BMW 3 Series is one of the cars with most problems, according to Auto Express. That's the auto build in the UK. Complaints about in-car electronic systems on the rise, customer report says. Everybody has been complaining about the quality of the software they have. So we probably have a small problem in not only in creating all the software that we need to create, but also in creating the correct software that we want to create. So, and then we don't even do everything that they want to do. What we want to have now is connected automotive cars, so cars that connect with each other, cars that drive autonomous or widely autonomous, which adds to the complexity. And we already see that there are some issues with that, and they need to be solved. So, what do we need? Well, we need some standards. And as Andrew S. Tenenbaum already said, as a guy lives in the Netherlands, it's in the university of that city that is our capital. I will never pronounce that name. I'm from another city. But he said already, the good thing about standards is that there are so many to choose from. And that's also the bad. Yeah, he's right, because there are many standards. But we should choose our standards that we use to make our software. We should choose them carefully. There are a lot of different types of standards. There are standards that do processes and methods for us, that they describe how should we proceed, what do we do, and what stage of our development, like automotive spice, or A-spice as people say. This is a regulated process from the automotive industry that says, okay, if you do exactly, you deliver every item there in this box, and you read the standard, and you proceed according to the standard, then nothing can go wrong. Well, I do not agree totally with this, but at least it's something better than, okay, let's just start and let's see where we enter. There are standards for interchange and connectivity, like AutoSAR. People might be surprised, but one of the big things in the AutoSAR is, of course, the interchange format, the ARXML format, is a standardized format where two totally different companies, even competitors, can exchange information and the exact right form of information. That's the AutoSAR standard. That's the vision that they had with AutoSAR by creating this standard, by having different platforms, but the capability of exchanging ECUs between different platforms without changing the software, without changing a lot of things, so saving work. It's not exactly happens in the practice, but okay, that has different reasons. Okay, domain standards, that's a third way. And we all know them, I think, and if you don't know them, shame on you. You should know them. There are languages, even for standard languages. OMG has defined a couple of them, XML, and one of them where I myself specialize on is the UML, the Unified Modeling Language. Good. Nice, there are a lot of standards. We can choose from a lot of standards, and we should choose wisely, but how do we implement these standards? We saw that automotive spice, really big, V model, but everywhere blocks. And if you read this standard, you will see that there are a lot of requirements to that standard, what you have to do. You have to follow procedures, you have to deliver documents, and you have to deliver information, you have to link information to each other. How do we do this? Well, we have tools. What? Tools? Exactly. And I haven't asked Andreas Tannenbaum, but I will ask him, because with tools it's the same thing as with standards. It is nice that you can choose from all those many tools that there are. And you will see here on the embedded world, all the large and the less large, the smaller tool manufacturers are here and want to sell their products. Even I want that. Simulink, MathWorks, they're in Hall 4. Very famous for their simulation. LabVIEW is one of the tools here. In automotive, you have a lot of tools where you can create network architectures of your car. You can until bits and bytes of your car. You can generate an operating system of it. DaVinci Developer, but also I always forget all the other names. Modeling tools, Enterprise Architect, No Magic, of course Rhapsody, what the tools that we all have ourselves in the program. These are modeling tools that you can use to follow procedures and to follow these standards that you have. And there are a lot more. I just copied a lot of them from the internet and just to show you some. But which tool should I select? Of course, a tool that we sell, yeah. You should preferably have a credit card or a bank account. No, it's just joking. But it is difficult to select the tools. Of course, you should set the tools that you feel comfortable with. And I noticed that a lot of developers, colleagues of me, they have their own tools that they like. They say, oh yeah, I like to work with this tool, I like to work with this tool. A bit of a disadvantage there is, what we also notice is the moment that people start liking a tool, they want to do everything with that tool. Yeah? So, I don't know if it's really visible, but I was a student once, so we didn't have much tools and we didn't have much money, but we had money for booze, of course, wine. So, but we had a hammer and we had a screwdriver and we had screws, so you can open the wine bottle easily with a couple of tools. They are not meant for it, and surprise, surprise, there are dedicated tools to do this. But normally we don't have this. Screwdrivers, kurkentrekkers in my own language. Even Andreas knows that. Good, that's what we always say, with a hammer in the hand, the whole world looks like a nail. So people try to use the tool that they like for everything. You notice that certainly with Simulink, it's an expensive tool, okay, you should use it. So, but you see people use it for everything, and it's not intended to do that. Although people say differently. But it's not the only tool. There are tools, more than sand on the beach, I would say, but that's not true. But there are lots and lots and lots of tools. So, how do we choose? Some of the biggies, here we have 4, PTC, Siemens, Dassault Systems, IBM. The big companies, they collect tools themselves. So they buy some tools and try to integrate these tools. IBM is a bit different. They develop their own Jazz platform, which is partly open source, which is a nice one. And so you can go to one of these companies and say, hey, I want to do this and this and this and this. I want to follow this standard. I want to follow automotive spice or ISO 262 or any other process and any other standard. And they say, yeah, we have the tools for that, no problem. Apart from the fact that there is a substantial price tag to that, you also have to figure out, okay, if I buy this from this company, then I am doing this only in this company. And these tools are integrated and bought together, but they all have their disadvantages. And to say, oh, from now on we only use PTC tools, or from now on we only use IBM tools, most of the developers inside the company will say, yeah, but I like that tool because that can do that, and that tool can't do it. So the integration there is, well, to say the least, not always perfect. So, what tools to use? You want to use the tools that give you the benefits that they have. There are some benefits to the tools. That's the reason why you started using the tools. What you want to do is you want to avoid repetition. If you have a total process where you have requirements management, modeling, SysML modeling, UML modeling, and you have modeling of PI loops or loop processes, and you have some other tools, then you don't want to have information there and the same information there. And even if you can synchronize this information or copy this information automatically, there's still always a danger that you have different versions of this information. Yeah? I just say global config or baselining. That's always a problem there. Sorry. So the information must be able to be shared between the tools, because if you make something in SysML, that always has a relation to requirements that I have. If I have test procedures, they have a relation with the requirements, because the requirements have to be tested. Is this requirement implemented? So information must be shared, and traceability is key here. Certainly for processes, certainly if you start speaking about safety and even security, then you have to have traceability, because you have to tell people, okay, this is the requirement, and this is where I implemented it, and this is where I tested that this requirement exactly is implemented. Huh? So there are some standards for that. IBM has a standard called OSLC, Open Systems Lifetime Connect. Andreas, help me, I always forget this. And that's a standard where tools can not only exchange information, but where you can say, okay, I have a certain type of information, and other tools that want to use this information just ask another tool via this OSLC link. Good. So not all the tools have this procedure. It is increasing. There are more tools that have it, although the implementation is not always 100%. There's still some work to be done. And so most of the time you do synchronization. My Rhapsody customers know this. We have the gateway or the requirements exchanger, where you can have the requirements from a tool and get them into Rhapsody, add information, add traceability information, and then export it back, which is okay, it works, but still there are steps involved there. There's always a risk that the information that you are at the moment synchronizing is not the correct information. So why not do an external tool to do this linkage traceability, or even further, that you do what is the requirement of all these standards is that you have review capability, so that not just one person does something, but other persons look at the same information and say, hey, you said that, but I not agree. It's wrong. You have a misopinion there, yeah? So that you can review, you can comment your code. So, and that you can have reporting, because the baseline of all the standards that we have is that you have reporting. Automotive Spice just relies on the fact that you have reports in between it. You can read the stuff and say, okay, this is what we have done. So, what I want to introduce today, another tool, but why not? Because when you use a tool that knows all the other tools and can communicate with all the other tools, you can use whatever you like in the process tab that you like. So if you like modeling with Enterprise Architect, no problem. If you like making your requirements with Excel, okay, it's not wise, but hey, if you like it, why not? If you have requirements in Excel, because that's mostly the problem. It's not that people want to continue doing something with a tool. They see that it's better to use another tool for it, like a real requirement management. But the problem is, we already have tons of information in the old format, so should we get that out and transfer it to the other one? There's a lot of work. Mostly it's not compatible. So why not introduce something that can do this all for you? So that's why I'm introducing to you SQL app, so System Engineering Collaboration. There's a federation platform where you can share information, trace information, where you can do reviews of information of all different tools that you have and all different process steps that you have. You can review artifacts of all the tools. You can open the silos, because normally we work with silos. All the tools have their own silos, have their own databases, and are very careful with their information, and even protect their information, because you should use these tools, which is logical. These people make money with it. Good. SQL app on high level means that's a semantic federation platform. It has a database, a graphical database behind it, Neo4j for the experts. It knows OSLC, of course, and a couple of other interfaces. And we make, to this tool, we have connectors for all the tools that you see here. So most of the modeling tools, a couple of requirement management tools. Of course, it speaks OSLC, it speaks Jira, Rational Team Concert, Magic Draw, Enterprise Architect, and all UML tools that there are. So you can read in this information from all these tools via the connector, and then you can, even if the tools themselves have no idea about baselining this information, you can baseline it and say, okay, I have a specific version and I have linkage information on this level, so I link the information there. I can do reporting from SQL App with all the information from different tools, and even if these tools don't know it. I can even view all the models and all the information from that in the original format. It looks exactly like it looks in the tool itself, even if you don't have the tool yourself, so for external people. Yeah, so if it is Doors, Rhapsody, Capella, Jira, GitHub, of course, there is version management in there. This half an hour, I don't have enough time to speak about all the advantages, but if you're interested in seeing a tool or seeing a demo or having more information about this tool, our booth is in Hall 450, Willet Software Tools, Oza, and Zodius. Okay, so with this, we achieve something that we call the digital thread. We are able to connect several tools and several informations there with the tool that you like, so developers can just continue doing what they like, continue using the tools that they like, and it will be maintained and being managed by SQL App. So, oh, sorry. That was a loose slide. This slide was already gone, so I know where it was. Cool, thank you very much. Are there any questions? Fragen geht auch, also ich spreche auch Deutsch. Mit Akzent. Rudi Carell. Fragen? Niemand? Ah, einer. One. Data pool, you mean? Andreas, hast du gehört? Thank you.
Is it on? Can you hear me?
Yo, good.
Yeah, okay. I'm expecting there needs to be some kind of data pool that connects all of these pieces together, right? Like, what is the system behind all of this?
Neo4j is the name of the database. So we have connectors that read all the standard formats of these tools, the standard databases. So not just APIs, but we read the format there and connect it into in the Neo4j database, which is a graphic database. So if you have connections between the information, the graphic database will tell you that. If you look at my slide here, here you can see an example where you have one requirement, and you see it's a bit bad to see, but there are connections between that. And if you click on another element, then they will automatically be fetched from the database. It's all web-based, as I see, so you don't need anything installed on your own system. That's all installed on a server. You can just, with web browser, go onto this. Of course, not everybody can do this. There is user checks and all that on there. So your data is as safe as it should be, because that's also a requirement of most of the standards that not everybody can change this data. Thank you for your question now. Okay, then I'm ready early. Thank you very much. Dankeschön. Merci beaucoup.